Hey families, it's Dr. Mommy again. I just want to follow up with our Lamarck assignments. Um, so let's dive in. It's a new setup, so I'm struggling a little bit, so be patient with me. Okay, so this is a spreadsheet that you should have, and you can see I've populated it. Now, there still are some gaps. For instance, I had trouble with the antennapedia females and white-eyed males crosses. A lot of times it was just that like the parents died before they could lay their eggs. So that's one of the reasons I call each class 8 instead of week 8. I didn't want anyone to feel any pressure. Um, and my crosses are going a little bit slower. I think it's a little cold where we live, so it takes the generations a little bit longer than 10 days. So you might notice that too. So it goes. I didn't, it's supposed to be fun, so I didn't want anyone to worry. But I have populated quite a bit of data that I did want to walk you through. Um, so, as I said, for each cross, I counted the total number of flies, if they had any kind of noticeable phenotype. For instance, you know, the number of females who had antennapedia, the number of males who had antennapedia, um, and then how long it took to knock them out in the fridge. And I did that day after day. And at the bottom, the spreadsheet is keeping track of how many flies total, and it's what's called a weighted average. And I'll talk more about averages and standard deviations in a minute. But for example, on the first day, there were 6 flies and it took them 6 minutes. So out of the total number of flies, 6 out of 66 so far, it takes them 6 minutes. And that goes into this average. Now, and the next day, there were 54 flies and it took them 6 minutes. They count a lot more towards the average, like 9/11ths of the average is coming from this day and how long it took them to get knocked out. And to be honest, I wasn't super rigorous about how much time it took the flies to get knocked out. I'd check around 6 minutes. They were usually knocked out by then, and so I noted the time. It was a little different from day to day. You can also tell that, the fridge wasn't working at first, so it took more like 20 minutes. And then when the fridge was working, it took a lot less. I think all of all of these data were taken when the fridge wasn't working so great. But or no, sorry, these are fine. Somewhere around here you've got numbers like 20 minutes. So yeah, so it goes. What else was I gonna say? So again, I sort of sorted these different crosses by whether both parents were cold adapted, which is in blue, one parent was cold adapted and one parent wasn't, which is in purple, and if both parents weren't cold adapted, they're in red. Now, again, this is probably, hopefully, going to be a little different for you. You're going to try to cold adapt different 5 different flies. So maybe your antennapedias weren't cold adapted, but your eyelids were. That'll give us a really good broad data.
All right, so I promised to explain averages and standard deviations, and if this is already familiar, I'm sorry, I'm not trying to insult your intelligence. I just don't know what you don't know. And you could also tell that after 30 seconds of searching, I couldn't find any graph paper, so here we are. All right, so imagine you're checking your flies every 7 days. That's the x-axis here. And you're noting down how long it takes to knock them out in the fridge in terms of minutes, and that's your time on y-axis here. So imagine on the first day, it takes your flies about 6 minutes to get knocked out in the cold. Next day, day 2, takes 6.5. Maybe on the third day, they're actually pretty sleepy, so it takes them only 5 minutes to get knocked out in the cold. Maybe on day 4, they're actually pretty energetic, and it takes them closer to 7 minutes to get knocked out in the cold. Another 5 minutes. It takes, or on day five rather, it takes them, only 5.5 minutes, um, and so on. So the average is kind of the middle of all of these, right? And then the standard deviation is kind of bracketing, it's the area in which most of your data are going to fall. So that's why I'm highlighting. It's kind of this area here. And you can actually do multiple standard deviations where, like, you're pretty sure that, like, 90% of your data are going to fall in that second standard deviation, but like 2/3 of your data are going to fall in that highlighted area. So when you see on a separate graph that the average is 6 minutes, this little horizontal line here, and the standard deviation is like a minute, you can be pretty confident that, like, when you take your next data point, it's going to take your flies about 6 minutes plus or minus a minute to get knocked out.
But I can kind of show you the summary so far. So for example, you can see some gaps in this chart because, again, I'm still waiting on some of these crosses. But for the crosses where I do have data, the average are the little horizontal bars for each cross. So this bar right here is for the Antennapedia females and Ebony males, and it takes them their kids about 6 minutes to get knocked out in the fridge. And you can see this, it's really not all that different from cross to cross. You might try to squint your eyes and make a case for some of them. For instance, this is, let's see, eyeless and eyeless seems like it's a little closer to 7 minutes. So you might be tempted to say, oh yeah, the eyeless parents, they weren't cold adapted. It takes them longer somehow to get knocked out by cold. And if you're asking yourself, okay, but is the difference between 6 and 7 minutes, is that anything to write home about? And in this case, the answer is no, because of these vertical bars, which are the standard deviation. And when you see these huge vertical bars, it just means that, like, some of these data were taken when the fridge wasn't working so great, so it took 20 minutes to knock the flies out. It wasn't because the flies were more or less cold adapted, it was because the fridge was a little warmer than it should have been. So, all in all, they're all right around the same time. And I summarized it in this table and chart down here. You've got both parents who are cold, and it takes them about 6 minutes to get knocked out. When moms are cold and dads are not cold adapted, it takes about 6 minutes. When moms are not cold adapted but dads are, it takes about 6 minutes. And when both parents aren't cold adapted, it takes about 6 minutes. And so it's clear that even though the parents are cold adapted, where it might take them an hour to get knocked out by the cold over time, after 5 or 10 rounds of being put in the fridge, that's not inherited by their kids. Doesn't matter what parents you come from, you do not inherit cold adaptation from your parents. So Lamarck was, pardon the pun, a little off the mark. It turns out that you can't inherit physiological adaptations from your parents. So at this point, you might feel kind of disappointed, which is okay. I definitely feel disappointed when I have to reject my hypotheses, but that doesn't mean you don't have an incredibly valuable data set. You do. And I'm going to prove that to you in the coming weeks. So I guess those are sort of the two takeaways from this, is that Lamarck's hypothesis we have to reject, physiological adaptations are not how we get new species. And a lack of physiological adaptation is not necessarily how species go extinct. And yet we know that there are species today that weren't always around. And we know that there are species that were around that aren't today. So we still have to figure out how that does happen, but we do know one way it does not happen, and that's Lamarck's hypothesis. Um, so coming up, we're gonna find out what Lamarck was missing. But these data, don't delete them. You're gonna need these. They're still incredibly valuable, and that's the other lesson is that even when you're wrong, you're getting a little closer to you still gain knowledge of the universe. These data are going to be really valuable. So the last thing I'll say is that what was helpful for me is putting in the children of some of these crosses into the fridge at the same time, and just seeing that I checked them after about 6 minutes and all of them were knocked out. And that was especially true with these crosses where, it was the same type of fly, like Antennapedia and Antennapedia, but different parents were cold adapted. So, if both Antennapedia parents were cold adapted, it took about 6 minutes to knock out. You can see here's where the fridge wasn't working so great, and here's where it got fixed. Um, but then, you compare them to where one parent was cold adapted and one wasn't. And again, it takes about 6 minutes to knock out the kids in the fridge. And if both parents came from the ready jar, none of them, they weren't cold adapted at all, it takes about 6 minutes to knock out their kids in the fridge. So I did that for both Antennapedia and Ebony. I didn't have enough white-eyed flies to do it with white-eyed, but you certainly can. And again, maybe you didn't cold adapt Antennapedia. Maybe you cold adapted vestigial flies. But anyway, I'm very curious to see your data. Believe it or not, and I cannot emphasize this enough, these data are really valuable. So good on you. This was a lot of work. I know at the beginning I said, oh, it won't take that long, but I ended up spending like 2 or 3 hours a day sorting flies. Hopefully it doesn't take you quite as much effort, and you're of course welcome to spread out these crosses. You don't have to do all 25 at once. Unless you're like me and you just love doing biology day in and day out. So yeah, stay tuned. Keep these data. You're gonna use the heck out of them.